Zeri, who's CEO and co-founder of a company called Inertian. They have some, from the looks of it, and we'll hear more, groundbreaking technology combining various forms of heat cap or energy capture. Before we get into his talk, what we usually do is do roundtable introductions. Then I will do a little bit about new members that have joined over the last period, and then I'll do a little more on introducing Hanif. So first, the roundtable introductions. What I'd ask is when I call, if you are on mute, please unmute, but put yourself back on mute afterwards, just so that the background noise level is lower for the presentation. Since I'm rambling right now, I'll start. My name is David Hindman. Long-time interest in the tech sector from back when I was doing biofuel development with Lafarge as part of their Cement 2020 program. I currently work for a sustainable fire suppression development company in Napanee called FireRain, and I'm the president and current board chair for Switch. Well, Darko, we'll get you out of the way as well.
Good morning, everybody. Darko Matovic. I am vice chair now of board Switch. Recently retired from Queens, mechanical engineering. Interest in renewable energy, biomass, especially biochar, and Switch member for 10 plus years, 15, let's say.
All right. Tatiana.
Good morning, everyone. Tatiana Zaremba. I am in commercial solar locally. I own and operate a 100 kilowatt FIT system. Presently working for myself. We finished up with Patry and their systems are all up and running now. Just waiting for the sun to come back this year. Up and running 8 years now, our commercial solar operation, and longtime Switch member, 10 plus years.
Thank you. Steve Isco.
Retired academic from Queens, and happy to report that my wife and I have just upgraded to a cold climate air source heat pump. We've replaced our gas furnace with an electric backup, and we're now using a electric hot water tank. We have an electric vehicle, so we've eliminated pretty much our use of gas.
Congrats. All righty, Jane Webster.
Hi, I'm retired from Queen's University too, from the School of Business, and I'm interested in anything to do with sustainability. I still have grad students, so I'm still working for Queen's for free. And I've recently published a few articles on the notion of greenwashing in the workplace.
Yeah, a constant issue, isn't it?
Yeah.
All righty, thank you very much. Mark Sibley.
Good morning. I'm retired from doing technical work in industry, and I also had a cold climate heat pump installed last summer, and an electric heat pump water heater. So I'm off natural gas, drive a plug-in hybrid. I'm co-chair of the Climate Leadership Working Group for this city and a neighborhood climate action champion.
Thank you, Mark. Hanif, as you can see, you're preaching to the converted here.
I was going to joke and say whenever I present to other groups, I mean, everyone's talking the talk. This group, everyone says, "Well, I've already converted to heat pumps and electrified." I mean, congratulations to this! It's amazing.
Yeah. So I'll just jump back in. I drive an electric car and have an air source heat pump as well. So it's just
amazing.
I think Paul McClatchy was next on my screen.
Good morning, everyone. Paul McClatchy here with the City of Kingston. I'm the city's environmental engineer and board member here at Switch.
Thank you, Mark. Rick Rooney. Oh, I still can't hear you. Yeah, not hearing you. You got it now? I don't know. Rick owns Quantum Renewables, a local solar installer and other tech implementation company. Is that a good summary? There you are.
Now?
Yeah.
Okay, sorry about that. Technical, not we're solar people, not computer technical savvy people. So owner of Quantum Renewable Energy, we install residential and small commercial solar systems in Kingston.
Thank you, Rick. Mame.
Hi, I'm Mami Ade. I'm a PhD student at Queen's in Environmental Studies and also the student board member at Switch. Well, I'm interested in learning all about like sustainable initiatives, and so this provides me a good platform to be conversant and get to know all the things happening. Yeah.
Perfect. Thank you. Where are we? Suresh? Pardon me if I'm getting that not quite right. Hello?
Yeah, hi. I'm a land developer. I have some piece of land in Kingston, and I'm interested in net zero development and its application.
Sounds like you've come to the right place today then. I see a Deborah.
Good morning. Yeah, Don and Deborah Hudson, Valley Pine Farm, south of Picton. I'm trying to retire. It's a hard thing to do on a farm, but I'm with the help of Quantum Energy. We've got solar, hot water, and 11 kilowatts of photovoltaic, and we're still a net producer by a small percentage, 2 or 3% of energy with the microfit. And so I'm just trying to keep up to date with the latest.
Perfect. Thank you very much. Peter Beck.
Good morning, everyone. I am not a Switch member. I receive emails regularly and, appreciate the opportunity to join you today. I just recently retired from the military after 27 years. And actually, I'm now working with TC Energy on their pump storage project in Meaford.
Oh, cool.
And this week I received delivery my 13 kilowatt solar system that I hope to install myself over the coming months here in Kingston.
Thank you. Putting in a shameless plug, a personal membership's only $50. So
thank you. Cheers. Looking forward to hearing the presentation today.
Thank you. Natalie Beauregard.
I haven't been to a Switch event for a while, but I attended a few a long time ago. I completed the Alternative Energy Engineering Technology program at Lambton College, and I used to work for SolCan here in London, Ontario, and their solar hot water company. So I'm very interested in the presentation today.
Well, thank you and welcome back.
Thank you.
And Natalie, our next project would be in London Health Hospital. We're going to talk about it.
Okay, I'm very interested. Thank you.
Awesome. Sarah Pitcher, sorry. Are you there, Sarah? If you are, you're on mute.
I think she's on the phone right now, David.
Oh, okay. We will move on then. Vicky Schmolka.
Hello, everyone. I'm Vicky Schmolka. I am a resident of Kingston and a cheerleader. And at some point, I hope to make the switch. And I'm very envious of those of you who've already done that.
Yeah. Well, we hope you join the club soon. And I believe that's Nancy Stonelake.
That's correct. I'm with the National Research Council Industrial Research Assistance Program. Our goal is to work with medium-sized corporations, small to medium corporations, to help them grow through research and innovation. I cover the greater Quinte region, and I have a microfit installation myself.
All righty. So, Hanif, as I said, I think that's everybody available at the moment. As I said, you're preaching to the converted today, so we'll see what we can throw at you as far as questions
I'm not
afterwards.
sure if you asked Tim Brown.
So, did I miss somebody? Where?
Yeah,
Oh,
you
sorry,
missed
Tim.
me.
Pardon me. Your child must have moved around on me.
Oh, I get hidden sometimes. I
No,
used to come out
sorry
to
about that.
Switch a long time ago, and it's been a while. And today's topic kind of grabbed my attention. I used to fabricate nanostructured thin film coating. So anything nanotechnology is my cup of tea, and I haven't come out to Switch for a long time. So it's kind of that. Well, this is my perfect excuse.
Okay.
I am currently looking for work, but I'm still in Kingston. But I'm glad to be back out at a Switch meeting, just to, especially for such an interesting topic.
Awesome.
I look forward to the talk.
Well, another welcome back. Thank you, Tim. Next, before we get into the main event, just we always try to acknowledge the members that have joined or renewed since the last presentation. This month we have a few individual members, Rit Nanda, Gavin Hutchinson, and Barty Borster have renewed their membership. So thank you very much. And so now we get into the meat of the presentation. I'm just going to read a little bit here just to get everybody up to speed in case you haven't seen what was in the postings. The Inertian team has invented a new category of product that they call Energy Cubed. This tech uses nanoporous materials and solar radiation to produce refrigerant-free cooling, emission-free heating, and power in one integrated system. The potential is to lower your utility bills by up to 70%. And as a converter to air source heat pump, I must say my utility bill went up. So that's one of the barriers for that conversion. Hanif Montazeri is the CEO and co-founder, PhD in computational physics from the University of Toronto. So congrats on that, my God. Pretty high tech stuff. This is his second startup, and before that worked with the Canadian and European space agencies, Altair Engineering and Bombardier Transportation. And with that, I'm going to stop so that we can get on to the main presentation here. Thank you again for joining us, Hanif.
Thanks, David. Thanks for putting, thanks, David and Darko for putting this group together. I think this is the first time that many converters in one room, which I'm delighted to present. So during the presentation, please feel free to stop if you have any question. I would be happy to clarify as we go. And I guess David introduced me. I started the Energy in 2016. Almost lost most of my hair for it. If you're wondering what happened to my hair, it's fun, but as you know, hardware companies are really tough to make. But we've been blessed. Maybe share a screen and it's just jump into. We've been blessed with the whole community support here. I guess we have originally started from Toronto, as I'm speaking from Toronto right now. And we have kind of a small manufacturing site in Scarborough at the moment. And we are raising capital to expand that one somewhere around GTA, hopefully. And then we are expanding heavily toward the south of California. Main reason is solar radiation and very expensive electricity. We think the culture matters a lot. So south of California has kind of quite a bit of electric cars owners. So we like that aspect. Anyway, so over the years, we've been supported by so many organizations, both in Canada, mainly in Canada, and recently in the US. I can't be, I mean, the support that we receive from so many organizations, IESO, STTC, Emission Reduction Alberta. We did a project in a farm in Alberta. It's been amazing journey, and seeing all that interest for our technology and the passion that the community has for building a new technology. The mission of our company, in a very philosophical way, and is that we want to produce green cooling, heating, and electricity at the lowest cost. Back to your David comment that cost is going to start going up. We think that, I mean, we need to reduce the cost eventually. The cost to owners has to eventually reduce to make it adaptable. And the same, like, I mean, Tesla is getting very popular because, I mean, its Model 3 is awesome. You could easily, it's very economic. You can buy it and replace your Camry with it. So we really have kind of the same mentality around that. Hopefully we could achieve that. And then maybe just jump into the statement of the problem. Like any other company who I need to say what's out there. I don't think I need to explain too much for this crowd, but to just set the stage. So for any building, operations, farm, office space, hospitals, you need 3 sources of energy to run it. You need heating. For the heating, traditionally we were using natural gas. Significant amount of CO2 associated with that. Everyone knows that. And then recently, the trend is around going after heat pumps. As you all know, heat pumps significantly reduce the CO2 emission. But there is one challenge with it would be electricity costs. So electricity costs could potentially go up. But the more, I would say, important challenge that I find it is the use of a synthesized refrigerant in the traditional heat pumps. We still use the synthesized refrigerant in the heat pumps. And I was in a conference last year, and they predict, I believe, 400 million new heat pumps are going to get deployed. And that would be quite a bit of a synthesized refrigerant that could cause problem. But significantly better than using natural gas, but still it's not zero emission. On the cooling side, it's the same old technology that was invented 1902 by Willis Carrier in Buffalo, New York. Uses synthesized refrigerant. We spend significant amount of our electricity cooling down our building. And then with the recent IESO kind of rates, as you notice, that the peak hours are going to be very expensive. And everywhere, it's globally, electricity is going to be more and more expensive. So that's another kind of perspective on the cooling. On the power, solar is green, unlike the 2 others. The main historical challenge with the solar has been conversion of 20% of the solar radiation into electricity. So that has been the challenge. And so everyone knows what would happen to the remaining of the solar radiation. It warms up the panel and dissipates away into the atmosphere. So while we are basically, our solar panel heat up and reduce the performance and dissipates heat to the atmosphere, at the same time, we might just use our natural gas to warm up our building, or use our heat pump to run our building. So that's kind of a mismatch in terms of energy optimization. So to answer all those problems that I kind of mentioned, we came up with this product. Not that we went after that. I'm going to explain how we came with that. But we have invented a new categories of product that we called it Energy Cube. Reason being is that we couldn't find any other name for it. Why? Because it's not necessary. It's kind of a heat pump, but it's not 100% heat pump. It's not a furnace. And it's not a solar panel. So it's a what it is a shiny box that we think is very beautiful. I could be very much biased, but that shiny box sits beside a building, goes to mechanical room. I suggest don't put it. It's beautiful. We put so much effort to make it beautiful, or goes anywhere you want to go, and then gets connected to a special type of solar panels. We talk about the different options, but typically hybrid solar panels. And then the total kind of combined effect of these two gives you electricity, cooling, and heating, all from one integrated package. And anything comes out from this box has absolutely zero emission because we don't have any synthesized refrigerant whatsoever. And everything comes from solar. So that's why I put the zero OPEX. So it's not zero OPEX to be accurate. I'm going to explain. We might use some electricity from grid. But here is, let's get into the what's in. So what is inside this box? Inside this box, the main part of the box is a technology that basically uses nanoporous material to convert hot water to cold water. So one side, you're sending hot water at around 90 C, 85 and above usually. You send hot water in one side, and this box converted entirely to cold water of around 8-9 degrees C cold water the other side. It doesn't have any, it doesn't consume technically any electricity. I'm going to show you a video, and it doesn't have any synthesized refrigerant. So water is a refrigerant. So for those of you who want to get to know more, here is kind of a kind of abstract thermodynamic cycles that compares the both technology. So on the left-hand side, it's a traditional air conditioning system or traditional heat pumps, right? You have an evaporator, you have a synthesized refrigerant in the loop, you have a mechanical compressor that gets connected to uses grid electricity. Refrigerant evaporates from evaporator, and that's why you get the cooling here. And then compressor pushes the evaporated, the vapor basically into the condenser, and then the cycle continues. So that was the cycle that was originally introduced for all the heat pumps and air conditioning systems. Now on the right-hand side, this is what that's our thermodynamic cycle. First, we use nanoporous materials. So what is the, I see team, and I think I should be very accurate in my language. The nanoporous materials, they have enormous amount of surface area. In our case, around 6 grams of our nanoporous materials have the same surface area as an entire football field. So they have gigantic amount of surface area. And so what happened is that because of that surface area, in our evaporator, we just put water. There's no synthesized refrigerant. Water sees the nanoporous material as a solid desiccant, as a dry solid desiccant. So water starts rapidly evaporating into the surface of the powder. And then at some point, the powder loses the efficiency of it because it gets soaked with the water vapor. And at that point, there's a valve here we close, and then we use hot water over a heat exchanger to dry the powder and push it to the condenser. And then once that gets condensed, then just like the traditional cycle, we basically kill the pressure and take it back to the evaporator. So that's kind of how the thermodynamic cycle works. As you could see, instead of using grid electricity to run the heat pumps or the chiller, we are using hot water. And so that's how the cycle works. Any question anyone has, or anyone want me to clarify here?
Any source of the hot water, please?
Yeah, source of hot water. Yeah, we gotta get back to the source of hot water.
Okay.
Yeah.
What's the substance, the powder that you're talking, and what's the nanoporous material made out of?
Yeah, so I can't kind of disclose the powder, but I could explain. So These powders, there's a variety of them. In our system, one of them is the base of it is silica gel that you are very familiar when you buy a new dress and shoe. There is a small package of silica gel in the corner of your box to keep it dry. So the main substance of it is from that. There are other kind of material that we are using, but there's a modification, a variety of those kind of silica gel and zeolite type. There are so much work that is happening at the moment on the powders. Did I answer your question?
How much hot water do you need?
What's that?
How much hot water is required?
Yeah, so I'm gonna go through the hot water source and how much we need and how we provide it in the next slide. Shrish, sounds good. Okay, so let me show you one video before we jump into that. So on the right-hand side, we put powder in the nanoporous material in this chamber. So in this chamber, there's nothing except just powder, dry powder. There is a pipe that connects it to another chamber that it's water at room temperature. So there's, as you could see, there's water in the room at room temperature, and there is a valve here that is not letting the powder see the water. Everything is under vacuum, a very low pressure. So all our colleague is going to do is going to connect water to or expose water to the nanoporous material. And I want you guys to see what would happen once that happened. And that's a real-time video. So as soon as he exposes it, water freezes instantaneously to -7 degrees C. No electricity involved, no synthesized refrigerant involved. And that's kind of how we get the cooling kind of out of the nanoporous material. So it's pretty, I found it very nerdishly cool video to show how does it work. Now, let's go through how we install our system. As you could see, we need hot water to run the system. The way we work, the way we install our product is like that. We install typically hybrid solar panel or alternative of that. So some people, for example, prefer vacuum tubes if they, depending on the energy need that they have. But in the case of hybrid solar panel or a combination of hybrid solar panel and vacuum tubes, on the roof, what you're going to get around 20 conversion of electricity, conversion of the solar radiation to electricity of around 20%. So you are going to get your electricity that typically you were going to get from your solar panel. The remaining of the solar radiation, we don't let it to escape. There is a heat exchanger underneath of this solar panel that heat exchanger basically grab and collect all the thermal energy in the solar panel, which is around 70%, in the form of hot water. And that hot water, in the hot sunny days that you need cooling, we convert that hot water into cooling using the cycle I explained. On the colder months of the year, let's say you are in November, in November, what would happen is that you don't need cooling, but your solar panel is producing hot water, and that hot water we provide you with heating for the billing. So imagine somewhere like in California, they would, I mean, let's say Los Angeles area, they barely have a cloudy day. If they do, I mean, they rarely have it. So all around the year, they have kind of access to have heating and cooling and electricity all from one integrated package. So one thing is that you could pay attention here is that per square foot of your roof, instead of having 20% conversion to electricity, all of a sudden you go to 90% conversion of the solar radiation into electricity. So that's what happened. Now, then I guess the question would be, what if you don't have a solar radiation? What do you do at that point? If you don't have a solar radiation, for the period of the time that overnights or the cloudy days, we are using grid electricity. So grid electricity basically provides the heating that we need. And the way it works is kind of like that. So maybe just more of an elaborated kind of explanation. So we in all our installations so far and in future, we are providing that all the different storages. So hot water from solar panel gets stored in a thermal storage. That, as you might know, thermal storage is very cheap. Electrical storage are expensive. It's around $140 and $130 per kilowatt hour to store. Thermal storages could be around $27, $25 per kilowatt hour to store. In that thermal storage, we have an immersion heater, electrical heater, so that basically it kicks in if we don't have enough solar radiation. So for places that like Los Angeles area, you barely use that one. For places like in Kingston or Toronto, in quite a bit in the winter months, you might use that electricity as a backup. Now that you have a hot water, in the summer months, we convert that one to cooling. And our electrical COP, so let me explain this one. So we provide cooling, and in the rejected heat from our condenser, typically at the very same time could provide you the hot water to warm up the building. Just one thing, electrical COP of our chiller, and we have audited report on that, and if anyone is interested, I could share it with you, is around 20. So for every kilowatt of electricity that goes to this box, we are producing around 20 kilowatt of cooling, which is significantly better than the traditional air conditioning system, because it's, as you know, is around 3.5-ish roughly. And our thermal COP is something between 0.5, 0.65. In the heating cycle, or electrical COP is around 1.7. So basically, if you have 1 kilowatt of heat you generate in November, we would provide around 1.7 times of it to the building. So because we convert it to a heat pump in the colder months of the year. Here is kind of a very and I guess the next question is that how do you compare it with heat pump, solar panel, those equipment? So clearly, this is the absolutely best case scenario. We pick up we want to impress you guys. So we pick up Los Angeles, that is absolutely sunny, gorgeous, with no interruption. So of course, so I'm going to present that one. And of course, for other places, this would go down. But just to give you a sense of the comparison of different technology, here we map all the CapEx and OpEx over 25 years. So initial capital that you need to put in, and then the cost of operation of different technology over the life cycle of the product, of different product. Again, this is for California. So the dark blue color is the initial capital. So what do we have? Baseline. Baseline is you buy your grid electricity from grid. You buy a traditional air conditioning system with chiller for your building, and you buy a natural gas burner to provide heating. And blue color is cost of cooling, red is the cost of heating, and yellow is the cost of electricity you buy from grid. So that's kind of the baseline that we have. Now let's start greening up our scenario. Let's install the solar panel to get rid of all the electricity you buy from grid. And I guess everyone agrees the energy business is a very complicated scenario. We could go over so many scenarios. So we just went with a very simple scenario, and we just, let's say, get rid of all the electricity from grid. So maybe that's not necessarily true, but let's do that hypothetically. So then you are cutting down on the cost of electricity you buy from grid, so you don't have that one. But your CapEx is going to go higher because you need to put solar panel on it. Now let's go another scenario. Let's say put a heat pump in the building. If you do that, one thing that noticeably happen is that the cost of heating is going to go up because electricity is more expensive than natural gas, particularly somewhere like in California. So you're going to start paying more for your heating, for domestic hot water and for warming up the building, right? And now let's go super fancy, put a solar panel and put a heat pump together in combined effect. So what would happen is that you are reducing that kind of reducing a portion of this electricity you're consuming, and the OpEx is reduced that. So in this super ideal case, as you could see, we have no OpEx on top of this one, because that box could provide all the heating and cooling and electricity for the building. However, we have the highest CapEx, as you noticed. So that's one scenario. Maybe I just to clarify that. So we do have one project, London Health Hospital. We have an MOU with them. They want to kind of retrofit the entire campus with our technology, and we did a very in-depth analysis for them. The total reduction of energy for them, based on the actual solar radiation for London, is around 40%. We have another hospital, Island Health in Victoria, BC, that they are not very blessed with solar radiation. They are better than Vancouver, but not much. For that place, which they barely have, I mean, they don't have enough solar, they would get around 30 to 35% reduction total energy bill. So that's kind of the actual number that you could expect. Now, what is more interesting for these companies or organization is our GHG saving. That is the whole different scenario. So let's imagine all these costs we are converting to blue collar. So blue collar is the CapEx and OpEx you pay for 25 years. And one thing I forgot to mention, why 25 years? Because our solar panels last more than 25 years, and our Energy Cube also lasts more than 25 years. So we have designed both of them to have the exact same life cycle. Now, let's assume all the cost is in blue collar, all the scenario. How much GHG saving you get for every scenario? So the best case, as you could imagine, it would be you have a PV and a heat pump. That's the greenest solution you could possibly have at the moment. And you get significantly more green GHG saving because you spend all the energy to green up your building. In compared to that, or Energy Cube, because it doesn't have refrigerations significantly and it consumes significantly less electricity. So we are basically getting much better GHG saving. And that's really gravitates so many organizations towards those who are really after the greenness. It's a really awesome way to green a building and save money. All our system comes with 5G connectivity, so you could control it remotely. And I don't want to brag about AI and machine learning. There are so much there. It's a very simple piece of technology that just optimize the machine or system performance based on the weather forecast. And weather forecast is very important for us because we have thermal storages. So we need to optimize how much solar radiation we should collect the day before. And then the customer behavior, it's also important for us. So we do have those I wouldn't say sophisticated is too much, but more comprehensive software to just manage the whole thing. We have, so in terms of our project, we have, as I mentioned, we have one system that we send it to, I noticed one person I forgot from Navy, Royal Canadian Navy in Victoria, BC, purchased our very first system. And it's a solar base, and we we almost install everything there. So that's the very first customer who was purchased the very first unit. Then we sold another unit to a farm in Alberta. It's a bigger one, it's around 50-ton system. We have sold one system to Con Edison, New York. So Con Edison, as you know, I think is one of the biggest utility company in North America. And they provide to, 3 million people electricity. So they purchased one unit, and they are going after the second building. So they want to install our system in the headquarters in Manhattan. So we're very excited about that. So that's kind of where we are in terms of the project. We are a turnkey solution. I mean, we find that the customer is very difficult for them to ask to do all the piping and everything. So from A to Z, we take care of it. And yeah, we could work with the local subcontractor, but we want to kind of streamline it for the customer. So customer write the check, but they don't need to get involved in all the different moving parts in each of the project that could drive them crazy. And that happened in Navy. So they just gave us a check, and that's how it went. And that's the actual look of the system. My electrical engineer Jack is standing behind it. This is the unit that we kind of sending to Con Edison, in case anyone wants to come by the way, before we ship it out, you're welcome to come by and take a look. And yeah, so I'm gonna stop here. Looking forward to your questions.
Wow, let me check if there's anything in the chat. I've got one thing that's going back to the, Hanif, thank you very much. That was very, very interesting, and spurs an awful lot of thoughts in my head. Anyway, the one question that's currently in the chat from Vicky is, understands that the powder is proprietary, but is there anything else that you can explain about it? Like, are there rare earths, for example, or is it just commonly found ingredients? I guess. Going back to the impacts of lithium batteries and rare earth mining and all of that stuff.
Yeah, it's a commonly used material. It's, as I mentioned, silica gel is almost free. It's very inexpensive, and we do have fancier versions that could be like compare with lithium ion battery, but we are not using them. So all the current powder that we are using or technology are very you could find them in enormous amount, and it's very inexpensive.
Perfect, thank you. I see Rick has his hand up.
Yeah, hi, thanks. That's a great presentation.
Thank you.
Hopefully my volume's working this time. Two questions. Wondering from a technical perspective, I'm just really curious how you obtain a COP of 20, such a massive increase.
Yeah. So Rick, as you could see, and I have Rick, if you're interested, we have hired a third-party company who audit the technology. Would be happy to share the report with you. But as you could see in the cycle here, you barely have any electricity. You would have electricity for running some of the pumps, control panels, and stuff like that. But we could produce electricity, basically cooling with zero electricity. And given that heat is always the waste product, so that COP is relevant to many applications.
Okay, and my second part is being a PV installer for over 20 years now, one of my skepticisms of solar thermal PV is that say somewhere in California where it is very bright, as the system works and the day progresses, the working fluid going through there is going to, I would think, get hotter than the uncoupled PV collector would, or PV module would. So I'm just curious, what kind of upper temperatures are you going to see during the summer with your working fluid? Like, are you going to be pulling the panel much higher than 25 degrees C with your solution? And if you're not, is that actually working for you as far as your heat pump action?
If I'm Rick, if I get your question correctly, so as in terms of the temperature, operation temperature, we prefer this temperature to be above 85 C. And then vacuum tubes, for example, as you know, they could easily go very high temperatures. They could even go to 300 degrees C. We don't operate at that number, but we operate around above 90 C for vacuum tubes. So we're using a combined effect of, depending on where they are. So we might just use a bunch of hybrid solar, and then bunch of vacuum tubes. So the rejected line, I didn't put it here, it goes very low temperature, and then that's why it goes to the hybrid solar. And then once the temperature heats up, then we go to vacuum tubes to go that final bump in the temperature.
Okay, so if I'm correct, then the collectors themselves are not going to see that 80 degrees C. They'll
Yes,
see much lower.
yeah,
Okay.
yeah. So the
Okay.
PV panels are not going to see that.
Okay. Okay.
Yeah.
Awesome, thank you. Question from Jane, will you be developing residential systems?
Yeah. So we eventually, yes. One thing that we noticed, I mean, right now, because we are at the earliest stage commercialization, we are expensive, clearly, because everything's like, I call it Aston Martin, it's a handmade, and we could even write our signature on every single part. So eventually, our plan is eventually go to residential and make it more compact. So this is like Model S, very expensive system. Yeah, but eventually we're going to go to residential. Yeah.
Yeah, all of us early adopters will be ready and waiting when when our current heat pumps expire. So,
and David, to that point is that there are so many incentives around our technology at the moment. If anyone wants to adopt it, even though we are expensive, but there are so many governmental grants that could significantly subsidize because it doesn't have refrigeration and it reduces electricity and everything. So right now, the cost is not a barrier for the customer at the moment.
all righty, thank you. What was next? The refrigerant water is presumably distilled and in a closed loop. Are there other more efficient refrigerants that could be used? Or are you deliberately using water despite technical limitations?
Water is amazing because the latent heat of water is 2200 kilojoule per kilogram. This is amazing refrigerant. It's bad because you need to keep a low pressure. So we mastered the low pressure very well the last 6 years. So we know how to keep the system at low pressure quite well. And therefore, water works very nicely for us, and it's cheap. And yeah, it's a closed loop, so we are not consuming it at all. But we could potentially use other solvent, like we have tested with what's the name? Forgot the name. We have tested other refrigerant, and we could go, let's say, freezing temperature if it's needed. But it's not in the right now. It's not in the commercialization pathway.
Right. All righty. And just a general question, could you speak more to the hybrid panels? Just maybe what you are defining as hybrid.
Yeah, so hybrid panels, we are not producing them, we buy them off the shelf. There are a number of manufacturers. One particular one that we have bought from is Abura from Spain. And there's a few in the US that they offer them, and they are pretty kind of look like a regular solar panel, as you could see. And then there is a small heat exchanger underneath of it. So as you know, I guess as Rick, back to Rick's question, as a solar panel warms up, they reduce the performance quite a bit, right? So what happened is that they run this the cold water, they send cold water to cool down the solar panel, and then they collect the hot water. So it's fairly simple, straightforward piece that they have. It's not the only version. There's a Swiss company that make it differently. They have there is a variety of them, and we are not agnostic in terms of what solar panel we put for the customer.
Okay. I've got a couple here. I guess you mentioned, the 25-year lifespan.
Yeah.
Is that largely because of eventual fouling of the powder?
Okay, so
I'm how have you tested for, since you're only 7 years old, a 25-year lifespan of the nanoporous material?
Yeah, so there are two pieces on this one, right? Is a mechanical system. I mean, I haven't shown the mechanical system. The mechanical system is way more complicated than the powder. I mean, that was the biggest kind of achievement we have so far. In a mechanical system, there are very little moving part, with the exception of 2 items that are moving part. And then based on the rotation speed and everything, we have kind of, we could predict that how long does it last. So that was an easy one. David, your question, the powder has been, nanoporous materials has been in use in industry for many years in other fields, in catalyst industry and other ones. So there is a huge amount of literature on how they last and how they perform. What happens is that very few have used it for cooling. So that's the new thing. But our plan is basically for a certain powder, every 10 years we want to replace the powder, and powder is not necessarily the most expensive piece of this puzzle.
Okay.
Yeah.
Until you can maybe eventually get to the point where you know that it will last the whole 25.
Yeah, but I mean, the powder, we know right now it lasts around 10 years.
Okay.
So we know that, and based on the available literature yes, there's just powder, absorb water, and then you dry it, absorb water and dry, and then you see how many times you could do that. And we have reports that thousands of times people have done that and nothing happens. And yeah.
Right. Perfect. Okay. Let me see. Okay, I've got some more stuff in the chat. I guess back to the similar question, what quantities of water are required and how much of an additional roof load should be anticipated? Or maybe that's more for the hybrid system.
Yeah, so inside the chiller, it's a closed loop. There's very little water, nothing to be worried. In terms of the solar panel, there's a loop of basically water that basically goes through that. Depending on the project, that would be, but it's not something significant that someone cares that much. And the roof space. So there's something about roof which is very interesting. Because our efficiency goes from 20% to 90%, so we gather so much of a solar radiation, the roof space, we are pretty good at it. I mean, usually let's say if you have a home, I guess the best way is one side of your home would cover most of your energy, because we gather quite a bit of a hot water from your roof. Yeah, but depending on location, we could get into the more details there.
Right. Okay. And Natalie's asking, is the solar collector vacuum tubes with silicone PV on top? I guess just a little bit back to your picture on the right there.
Yeah, so this particular version is just regular silicon PV with a heat exchanger underneath of it, but there is what we could sometimes do. We connect this one to regular vacuum tubes, the standard vacuum tube, to bump up the temperature to higher temperature that we need. There is the way that you describe it, there is a Swiss company who has done exactly what you explained. Basically, they put a vacuum panel on top to collect all the heat.
Wow. Okay. Thank you. Here's a quite interesting question from Vicky. In the worst case scenario, fire in the building, earthquake, truck driving into the system.
Yeah.
What are the environmental risks for anything that is released from the system?
Yeah, that's the best one. Thanks for that question. I could put my kid beside that, and an earthquake comes, as long as it doesn't hit it, I'm fine. And that's beauty of this one. For those of you who know, there's an alternative technology called absorption chillers that use lithium boromide and ammonia. And I don't want to have my kid around that if the earthquake hits it. So it's water, and then the powder are non-toxic. You could touch it. And so it's very, very clean and safe. That's really one of the, I mean, City of New York really like that, because they have a bunch of absorption chillers, and it's a massive problem for them because of those problems that you mentioned.
Okay, perfect. Thank you. I had one more. How many employees do you currently have?
Right now we are around 15-ish roughly, and yeah, we are raising capital. Hopefully go.
Yeah.
Expand faster.
Yeah. Good luck. The company I work for, we're finding that capital thing kind of tough at the moment, but
yeah,
you're in a different space than we are. So anyway, and I see Mark Sibley has his hand up.
Yes, my question is about the inside the building part. Is it just conventional radiators? Can you speak to that?
Yeah, so we don't really touch the inside the buildings much. Basically, your traditional fan core or whatever you have, because we provide the same temperature for heating, 60 C, for cooling around 77 to 8 C. So you could stick with whatever you have. And we just provide basically cold water to the cold tank and hot water to hot tank. And then the buildings would take it from there.
So this could be air forced over coils,
Sure.
or
Yes.
it could be, radiant heat through, a water system.
Yeah, so I mean, our mission stops right at the border of the building. So we
Okay.
provide the 60C and 7C, and then whatever the building chooses to adopt, then they could go for it.
Right. Okay. I can't see everybody's tile, but are there any other questions? If so, unmute yourself and ask it. I don't see any more in the chat. So I guess in that case, Hanif, if you're,
Yeah.
Perfect. Thank you. I don't see any more hands up. So thank you very much, Hanif. That was very, very interesting. I am always exceedingly surprised and overjoyed by all the cool tech that we get to showcase through these open meetings. So you're certainly part of that list. So this has been awesome.
Thanks, David.
What we normally do now, and we'll roll through it, is move on to sector news. What we try and do, part of our goal, for those who don't already know, is the networking piece and keeping abreast with any and all sort of energy related technologies that support GHG reductions and sustainability. So I'll just go through my current list. Anything specifically on fuel cells? Doesn't look like it. We've heard about one application of solar, or anything else?
Hello.
Hello,
Fuel
Natalie.
cells.
Yes.
I watched a very interesting webinar on hydrogen the other day, and it's the Hydrogen Science Coalition that presented, and they made some very good points about how expensive it is to use hydrogen and fuel cells. So I've been very interested in fuel cells for many years, but you need wind and solar in order to produce that energy, which is better used directly. So look up the Hydrogen Science Coalition for good information on hydrogen.
All right. Thank you very much. Yeah, I'd say as with every technology, it has its use cases, and I see Rick has his hand up on something here.
Yeah, just a couple of points. Everybody who's got a net metered system, there's very exciting things going on right now. The Energy Board had made a ruling a number of months ago that currently, if you're net metered, most of you know you're switched from a time of use meter to tiered pricing. So you just get one fixed price. The Energy Board ruled that customers should be allowed to choose what billing they want, and equally, if they're a producer, choose what kind of payment they're going to get or benefit. So it was supposed to come into effect May 1st. We've kind of pushed the utilities to find out if this is available yet. They said that actually, the way the rules read, they have to have it in place by November, so it'll probably not happen until the end of the year. But the net effect of this means that if you're a net metered customer, you're going to, and you choose time of use metering, you'll be producing during peak. And what that turns into could be a 40% greater benefit to the payback of your system. So it's a massive movement. This is something that we've hoped for a very long time. We don't need incentives. We don't need grant programs. We just need solar customers to get paid time of use. And especially with this ultra low nighttime pricing and high daytime pricing, if that's also applicable, solar customers could be in a massive benefit if they're able to get that. So we'll certainly let you know as things develop.
Wow. So was the pushback originally because they didn't have the computational infrastructure to be able to do it in real time?
It exists. It totally exists, David. They do this down in California. It's just we don't have Measurements Canada hasn't approved for use of a bidirectional time of use meter in Canada because there's no market for it. So it's just a matter of if there's a program that demands it, they just need to start buying certified bidirectional time of use meters.
Okay,
So
to take advantage of this, you'll have to retrofit your meter?
Nope, not at, well, yeah, ultimately you will. Yeah. Which your hydro provider should, your LDC should take care of switching if you ask to switch from tiered to time of use. I believe that should be just part of your billing.
Right.
Yeah.
Very cool. Thank you for that.
Yeah, great. Thanks.
Anything else on solar?
Yeah.
Okay. Tatiana?
Yeah, sorry, David.
No worries.
I'm not sure if everyone saw the tax notices that came out at the end of March for the ITC clean economy tax credits, but those for both solar and hydrogen are quite significant in the commercial realm, and you should have a talk with your accountant. You're not already looking into that for some of the commercial people on solar. It means some great new possibilities for tax credits.
Perfect. Great. All righty. Move on to bioenergy. Nothing around the table today. All righty. Electric vehicles. We should probably have another session on EVs because there's so darn many options out there now. It'd be a good topic to get an update on the various technologies that are rolling out, how the price reductions from Tesla are impacting that world and all those good things. In the broader sense, transportation. Nothing today. Wind. Alrighty. Geothermal.
David?
Yes.
Wind. There
thing.
is a petition that folks can sign to encourage the government to reverse the moratorium on wind power in the Great Lakes. Just so you know, I can't remember the name of it, the organization, but that's something we need.
Yeah, no kidding. Yeah, interesting that the current provincial government canceled all these contracts and installations and everything, and now they're screaming about starting new gas-powered plants. So anyway. Yeah, we all shake our head around this table, don't we? I will go no further on that topic. Anything on geothermal? If I haven't already asked that. Water power.
Geothermal and water, of course, everybody's already on the green energy grant that's put out, the extra $10,000 from Enbridge. That's a residential program that has quite a bit of money, and then another $40,000 of zero interest loan money available too. And geothermal, solar, all of it.
Okay, so the Enbridge programs. Yeah, one of the, I mean, those of us who've done conversions of one form or another, it's the barrier as much as anything is the time to get through all the processes and have the inspections and everything else. It's we need to figure out how to simplify that process.
Super happy to see new inspectors, Les Carr, come into our region to do those inspections. I was able to get really quick for that NRCan application, him in here.
Okay.
It's $500. It's well worth the time.
Yeah, I know, and I know Sustainable Kingston's doing a good push on that now that they've merged with Red Squirrel.
Nice.
Did I mention water power? I think I did. Education, anything in general in education? Conservation? Anything on green buildings?
Yeah, one thing about 2 months ago, there's a paper published in one of the nature journals from a group at Colorado. They developed a film, a very thin film, which is quite transparent, but essentially it converts a one pane window to double pane with a high resistance to heat flow or cooling. And if you put it in between a double pane window, it's like having a solid wall in terms of insulation. The material is made from cellulose, but somehow they make it transparent, but it acts as an insulator. I wrote to them, and the savings from this alone in retrofitting could be huge. I also asked the inventors if they could put something in the film that would reflect UV light to keep birds from hitting windows. Anyway, I can send you more information about that.
That would be cool. That would be a very interesting future presentation.
I'll see if he's interested.
Yeah, exactly. Yeah. Alrighty. Thank you on that one. Sort of goes into where was I? Green buildings, I guess I was. Anything?
Yes, David.
Yes.
On green buildings, it's as a neighborhood climate action champion, the project I'm doing is deep energy retrofits of your home. And so that talks about cold climate heat pumps and conversion to electricity and upgrading insulation, air tightness, and so on. And I've developed materials, and so far I've had discussions at environmental fairs and the like. So I plan to keep doing that. But if anybody wants to look at the materials and help me upgrade them, I'd be grateful.
All right. Well, thank you. And is this part of the city? This is part of the city's climate leadership plan,
Yes,
isn't it?
yeah. Yeah, we've got climate action champions for each electoral district.
Right. Yeah. And Mark and I are on the buildings and energy. I forget what their term is. Subcommittee, I guess.
Subgroup of the
subgroup. Yeah.
Climate leadership group. Yes.
Yeah. So. Anything on collaboration?
Green building.
Pardon me, Tatiana?
Green building and collaborations.
Yeah.
CDK Solar has just gotten a distributorship with My Trucks, which is kind of on the comment that was just made. The fancy solar panels with the printing on the front that the birds won't run into makes them look pretty. I think CDK is a local solar installer that has the distributorship on that now. Really cool panels.
And as we start building entire buildings out of solar panel walls, going to get even more important. Anything else? Any other sustainable energy items?
The state of New York has just signed into law legislation that prohibits the installation of gas furnaces or stoves in new buildings. There are a number of exemptions like restaurants and height of buildings, but that goes into effect, I think, next year. I keep wondering why Utilities Kingston keeps renting out gas hot water tanks, for example. I don't know why that happens, but.
All right.
The answer I've been given is that they are legally obliged to at this point with the way the regulations are written.
Hopefully someone's working on that change, but yes. Having lived in the States and used a gas stove, I do enjoy how they work, but now that I know the implications, I'm glad I don't use one. Anyway, I just want to go back to something on the fuel cell side. Actually, maybe I mentioned it last month. There's continued to and fro as Ontario looks to get more energy reserves with large-scale battery energy storage facilities. 250 megawatt, 200 megawatt discussions going on around the province. I sat in a few weeks ago on a webinar about the fire hazards of these, and currently best practice is to walk away and let it burn. So that's an awful lot of damage that can happen, especially if the siting is not done right, if the individual modules are not spaced far enough apart and you get thermal runaway between them. So as these become more common, there's going to be the pros and cons of these large scale battery energy storage systems. So anyway, Darko. Unmute, yeah.
Yes, just an interesting alternative to this battery storage facilities is a Swiss company. Basically has a very efficient, how to put it, lift. There is a well-known technology for storing energy by pumping water in upper reservoirs, and that's well known. But this is a much simpler thing where you basically haul up huge boulders of concrete, like, I don't know, 1,000 tons or something like that. And then you let them slowly descend when you need energy, and basically running just mechanical without any turbines and so on. It's very efficient and, shall I say, no fire hazard there.
No.
But that's a technology that's being now deployed at several places.
Yeah, actually, when I was at Queens, there was talk of building towers and just, as you say, hanging cinder blocks, large scale cinder blocks off of them, and just letting them go up and down as nighttime versus daytime use and all that.
Yeah.
Yeah. Anyway, are there any other questions, comments? If not, is there anything else in the chat? Just a sec here. Lots of many thank yous to Hanif in the chat. So I will echo that yet again. A pleasure to be introduced by Ian Arthur, and we wish you luck with the deployment, because how do you make some money off of this now that you've got the cool tech together?
You start selling.
Yeah, you start selling. Yeah,
began selling. So I guess thank you so much, David and Darko, for the opportunity. I appreciated that. And anyone else, I put my email in the group. If you want to reach out, if you want to deploy any new project, there is lots of kind of incentive, as I mentioned. So please reach out, and you want to learn. If you want anyone wants to come by and take a look, please come by.
Awesome. Well, thank you very much.
Thank you so much.
And with that, just say that we will be having our next open meeting June 2nd. It's quite early in the month. We're still working on the speaker for that one, so stay tuned to your emails. And with that, I will let everybody go and have a good Friday, and enjoy the first nice long weekend, or first nice weekend since that scorcher we had a few weekends ago.
Thank you.
Anyway, thank you all again.